What is the Higgs boson?
Higgs boson, that's a particle proposed that you can think of it as a kind of it's like think of it like molasses. Okay? Well, okay, not molasses. It's a field through which all particles move, and the interaction of those particles with that field endows them with the mass that we measure for them. It is granting them the property of mass. We have yet to find this particle, but if we do...
So mass is not explained presently.
That's correct. We just measure...
We don't know why we get fat. We don't know why something has mass right now.
That's correct.
And so now let me ask you something. If you build, let's say you build an equation this way. You've got an equation over here. You built it, and it's a house, okay? And you've got another equation over here that works. It's another house. But in your mind, you think these two houses are actually probably should be one house. You invent something that fits into the shape between the two houses, right?
Yes.
Like you've got a shape between two houses. Goes, okay, there's something in the universe that is the shape of the space between these two houses.
Yes.
Does that necessarily mean that thing is there?
The history has shown that almost every time we propose something that connects one house to another, if those two houses themselves work, there's something in between them connecting the two. For example, in 1930s, we had this experiment with the 1930s. Quantum physics is in place. We start probing the atom. We find out there's an atomic reaction, a nuclear reaction, where there's some missing energy. We account for all that, and there's something missing. We say this much energy here, and then it's missing here. And we swear we accounted for everything. Fermi comes up, a famous physicist, said, I bet there's a particle that came out of that reaction that escaped with the energy before you had a chance to measure it.
E equals mc squared.
Well, that would have endowed that particle with its energy to do so, the mass to do so. And even mc squared is in every one of these, it's all over the place. It's written with E equals mc squared. The point is, he hypothesized the particle, gave it the properties that it would have to account for what was seen. That's your conduit between the two houses. Then he says it's got to have this much energy, and it's got to be pretty hard to detect because we surrounded this in lead, and it just went straight through the lead. So I'm going to propose a particle that's hard to detect. And it's got to be little, because there's not that much mass, and it has no charge, so it's neutral. So he called them neutrinos, little neutral ones. He hypothesized. He said, let's look for them. 20 years later, they were found, neutrinos. And now we kept them coming out of these reactions. He built the porch, the walkway between the two houses. Practically every time you have two working understandings of the world, and they have to coexist in the same universe, there's something that's going to connect them. It's like electricity and magnetism, previously discovered as separate things, until Faraday and Maxwell said, hey, wait a minute, this works and that works, and they kind of smell like each other, though maybe they're the same thing. So a whole theory came out to put the two together, and it is the theory of electromagnetism. You know this word. You just take it as a single word, but those used to be separate concepts. So we're going good with this. We're on a roll here. So why not continue?